All right, hi there. I'm looking at section 1.6, solving linear inequalities in this video. We'll try to make this one a little shorter than the last one. There's a little bit less to cover. Plus, this one piggybacks off of the last one, so if you've got a better handle on solving equations, then solving inequalities should fall right from that. All right, so with that said, solving inequalities, like I said, is very similar to solving equations. The biggest difference is instead of an equals mark, you've got an inequality symbol in between. It can be less than, greater than, less than or equal to, greater than or equal to. Your solution will always be written in interval notation. We'll talk about that in just a few moments, but we've already spoken about interval notation in a previous section, so we'll just be hitting that again. And then there are two times, this is the biggest new piece for solving inequalities, is that there are two times when you have to change your inequality sign. And the first one is the most important, or I mean, they're both important, but it's critical that you do this. Anytime you multiply or divide by a negative number in order to solve the problem, you have to change your inequality sign. And then if your inequality sign is backwards, as in the example that I have below here, 3 greater than x, you always want to be able to read so that your letter is on the left. So we would rewrite it so that our letter is on the left. And so when I do that, x would be over here on the left, the 3 would become over here on the right. This was, at this time, like you can think of it as like an alligator mouth. It was eating the 3. When I rewrite it, it still needs to eat the 3. So x is less than 3 would be your final answer there in terms of making sure that your letter is on the left. I think that hopefully that helps you. Letter on the left, okay? All right, so let's come down and I'm going to just do I think I'm going to do 1, 2, and 5 with you, okay? I'm going to let you pause the video and try 3 and 4 on your own and check yourself with the posted solution key. All right, so looking here in number 1, it says they want us to solve the inequality and write our solution in interval notation. So looking at number 1, it's the same goal when solving an inequality. You want letters on one side and numbers on the other. So in our case here, this 9x, the letter is over here already by itself. So I'm going to bring the x over to join it. Do the opposite. It's the same as, like I said, the same as you solve an equation. If you cross that inequality sign, you've got to change the sign. So I'm subtracting x from both sides. So now I have 4 is greater than 8x. Divide by 8. Remember, you always divide by the number beside your letter. 4 divided by 8 reduces to 1/2. So 1/2 is greater than x. This is backwards, right? So since it's backwards, let's rewrite it. So x is, flip the inequality sign. I'm going to change my color there just so I emphasize that for you. So here we say x is less than 1/2. If you take the time to do that, so this would be the solution to the inequality. If you take the time to do that, then whenever you go to look at a number line for this inequality, you don't have to do the number line, but sometimes it helps whenever you're doing your interval notation. I'll just put a 0 here. We'll just guesstimate here it's 1/2. 1/2 then, because it's less than, would get a parenthesis. And notice how your inequality sign is pointing to the right, so I'm going to shade to the right. So here's my parenthesis pointing to the right, so I'm shading to the right. And so then if I were to write this in interval notation, okay, my shading is coming in from negative infinity and stopping at 1/2. Like I've already said, infinities always get parentheses, and then the 1/2 would also get a parenthesis here. So here's your solution, here's your interval notation, final answer, okay? All right, let's look at number 2. Looking at number 2, just simply because you've got fractions, and I just want to make sure that I hit on those as much as I can to give you as much guidance as possible. So I want to get rid of these fractions. And, I keep saying to get rid of them. It's not necessary, but I think it's helpful, okay? And like I said before, there's more than one way to solve something. So as long as you get the same final answer, then I'm not going to pigeonhole you and say you have to do it my way. All right. So back to the problem. Looking at my denominators here, we're looking for a number that 5 and 2 will both go into. So hopefully you agree. That would be 10. So I multiply this entire equation by 10. With my fractions, remember, divide by the bottom number. Whatever answer you get, multiply it times what's up top. 10 divided by 5 is 2. 2 times -3, -6x. 10 times 2 is 20. 10 divided by 2 is 5. 5 times 1. Okay. Next step, I'm going to subtract 20 from both sides. Cancels out over here, so -6x is less than, that's going to be what, a -15? Then divide by -6. This goes back to number one. If you multiply or divide by a negative number in order to solve the problem. So in order to solve this problem, I just divided by a -6. So because I did that, I have to change my inequality sign. And I changed that inequality sign, so now I have x is negative over negative is going to give me a positive. And 15 over 6 can be reduced. 3 will go into both of those. So 15 divided by 3 is 5. 6 divided by 3 is 2. So x is greater than 5 halves. So that would be my final solution there. And when I go to graph it, thinking about it under a number line, I have 0, 5 halves. 5 halves will also get a parenthesis this time. And the inequality sign is pointing to the right, so I'm going to shade to the right. So then if I think about my interval notation, this graph starts at 5 halves and goes to the right forever. So that would be infinity, parentheses on both. Solution, and then your interval notation. Okay. I don't see anything too different in number 3 or number 4, so I think you'll be able to follow along from the solution key. And you know what? Since number 5 is another fraction one, it might be a good idea for you to pause the video and try that one too on your own, just to make sure that you're tracking with these fractions so that you don't always just wait for me to do it. But nevertheless, I'm going to go ahead and do it just so that you do have at least one, another one from me. All right, so pick out my common denominator, a number that 2, 3, and 4 will all go into. Hopefully you agree with 12. 12 divided by 2 is 6. 6 times 1, 6x, minus 12 divided by 3 is 4. 4 times 5. 12 divided by 4 is 3. 3 times 6. Okay. At this point, 18x is sitting over here all by itself, so let's take the other letter over to join it. 6x is over here and it's positive, so to take it to the other side, do the opposite. Subtract 6x. Negative 20 is less than or equal to 12x. Divide by 12. Negative 20 over 12 can be reduced. Divide them both by 4. So that would be a negative 5/3. At this point, it's backwards. So let me rewrite. X is greater than or equal to negative 5/3. That's the only thing that changes is the inequality sign. And again, you're really saying the same thing. Here it is eating the x. It's still, when you rewrite it, it still needs to eat the x. I think about my number line. Negative 5/3 would be over here. This time, because it's an equal to, greater than or equal to, it's going to get a bracket. It is pointing to the right, so I'm going to be shading to the right. Interval notation then, it starts at negative 5/3 and goes to the right forever. The negative 5/3 is greater than or equal to, so it gets a bracket, and of course infinities always get parentheses. All right, if I flip it on over to the next page, compound inequalities. So for a compound inequality, the only thing different that you'll see here, and like in number 6 and number 7, is that this means that x is between these two values. So what needs to happen is that I need to get that x in the center all by itself, and whatever operation you do in the center to get rid of those terms, whether here like it would be adding the 3 over, whatever you do in the center, you have to do it to the left and the right as well. Okay? So I'll do number 6 with you, and then I'll let you do number 7. So here in number 6, the only thing that I need to do is get rid of that 2 beside my x, so just divide by 2. Do it on the left and the right. So that way in the center, those 2's cancel out and just leaves me with a single x, which is what I wanted. Negative 6 divided by 2. 8 divided by 2. Okay. So if you recall, if you were to go to graph this on the number line, we'll have negative 3 on this side, a positive 4 on this side. Negative 3 is right beside the less than or equal to, so it's going to get a bracket. 4 is beside the less than, so it will get a parenthesis. And then these are always shaded in between. And then I can write, okay, well my interval notation then would be from negative 3 to 4, bracket, parenthesis. So here's your solved inequality. There's your number line. Here's your interval notation. Okay. Number 7, just think about, if you were to just ignore this for a second, think about how you'd solve that equation, right? you'd add 3 to both sides, and then you divide by 2. So now think about when you add 3 to both sides, do it to the left and the right, get your answers, and then when you divide by 2, do it to the left and to the right, as well as in the middle there, okay, so that you arrive at just a plain old x in the center, like so, okay. All right, let's look at, I'm going to do number 8 and 9 with you because they are a little different. Well, actually, yeah, I'll do 8 and 9 with you. All right, so looking at number 8. This is, it's also a compound inequality. It's just using the word or. We will talk more about and or statements in the next, I can't remember if it's the next, I think it's the section after next. We'll talk a little bit more about these and or statements with inequalities and how that plays a role in the graphing. For this next one, though, we have 2x is less than 8, so we want to solve for x, so we'll divide both sides by 2. So we have x is less than 4. Or over here to solve, add, not add, sorry. This is plus 3, so I need to do the opposite, subtract 3. So x is, let's just come on down here. X is greater than or equal to 7. If we think about a number line then, I've got 0, 4, and 7. 4 is going to have a parenthesis, and notice how it's pointing to the left. So I'm going to be shading to the left. Get a different color. So it looks like that. 7 is going to have a bracket. It is pointing to the right. So I'm going to be shading to the right. So now, in terms of, okay, now writing what's being graphed here, on the number line, it's coming in from negative infinity and stopping at 4, parentheses on both. Unite that with the last leg of the graph, starting at 7 and going on forever to infinity, like so. Okay? All right, so let's look at number 9. In number 9, what I would recommend that we do here is that, we've got this fraction, and I've been advocating, let's get rid of them. So let's talk about this one. If I get rid of my fraction, I'm going to have to, and the only fraction I have here is 1/2, so my common denominator then can just be plain old 2. But notice how this is a negative sitting here. So let's go ahead and kill 2 birds with 1 stone. Let's go ahead and just get rid of this whole negative 1/2, and we can do that by multiplying the whole piece by a negative 2. So negative 2 times negative 5, positive 10. Now remember our rule, if you multiply or divide by a negative, you got to change that inequality sign. So I'm going to emphasize that. Now, negative 2 times negative 1/2, a negative times a negative is going to give you a positive, and so half of 2 we know is just 1. And then the 3x plus 1, that's in parentheses, so it's protected by multiplying. So I don't think I've mentioned that before, but whenever you multiply by a common denominator, if you have parentheses in your problem, then it's in parentheses and it's protected, and it won't get multiplied by the common denominator. Okay, only things that are outside get multiplied by that common denominator. All right, so now again, you're multiplying by a negative, so this inequality sign also changes. And then negative 2 times a positive 7 will give us a negative 14. Now, from here, I can just distribute this 1 through, so I have 3x plus 1 is between now 10 and negative 14. A couple of steps. I want to get closer and closer to getting this x all by itself, so let's take 1 over, subtract 1. I'm doing it in the middle, left and right. So in the middle, it cancels out, leaves me with just 3x. So now 3x is between 10 minus 1. Negative 14 and negative 1 give me negative 15. Last step to get this x all by itself, divide by 3. So now x is between 3 and negative 5. Now at this point, it's technically not wrong because it's greater than, so it's going from largest number to smallest number. But typically these between problems are written still with your x in the center, but it goes from smallest number to largest number, and we use those less than signs. But technically it's the same thing. And then then if we were to graph it on the number line, it is still coming from negative 5 to positive 3. parentheses on both, and we'd be shading in between. So -5 to 3, parentheses on both for your interval notation. Okay? All right, and let's wrap it up here with an application. I'll do number 10 with you and let you see number 11 from the solution key. Try it solo and then try it. Check yourself by the solution key. So here, number 10, Acme movers charge $100 plus $30 an hour to move you across town. Hanks movers, though, they charge $55 an hour to move you across town. For what lengths of time does it cost less to hire Hanks movers? So let's first, before we try to tackle how to solve this, let's first identify some expressions here. So for Acme, going by our first sentence, it says that they charge a base fee of $110 plus $30 per hour. So you could put an H there, or I'm just going to put an X, but you could use any letter you wanted to. So they charge, I put 110, they charge $100 plus $30 per hour. Okay, so this would be how you would calculate how much they would end up charging you if you were to hire them for 5 hours or 2 hours. Okay. Hanks movers, on the other hand, just charges a flat $55 per hour, so we could calculate their cost by just saying 55x, where in both of these equations, X stands for the number of hours that you hire them. So now let's look at our last sentence. It wants to know then for, let me write that for X equals the number of hours. For what lengths of times does it cost less to hire Hanks movers? So essentially, I'm looking for where is Hanks, right? Where is Hanks movers less than Acme? So now in place of Hank, I'm going to put his expression, which is 55x, less than Acme, 100 plus 30x, and solve for x. So our goal is to get x all by itself, so I subtract my 30x. There's just a 30 over there. There we go. Cancels out. 55 minus 30, 25x is less than 100. And then last step to get x all by itself, divide by 25. So x is less than 4. So any amount of time less than 4 hours, Hanks is cheaper than Acme. So we could just say here, less, if I can spell, less than 4 hours. All right. Let me know if you need anything. Thanks a lot. Bye.